Alright, good evening everyone. Welcome to lecture 7. Today we'll be covering the period from AD 1250 to 1769. For starters, there's a few important European developments. Around 1520, the first muskets appear in Europe, specifically developed in Spain. This was essentially a heavy derivative of the arquebus, which we saw last time as the first true firearm. The musket fired a larger and heavier projectile, which gave it significantly better armor penetration. So at the time, it could penetrate the thickest armor worn by knights at a distance of 180 meters. And it had longer range than the arquebus in terms of just capability, but the accuracy was still pretty low, so if you were attempting to shoot a musket at a human-sized target, you didn't really have a chance to hit the target at all beyond 70 meters. But when you were firing volleys of musket fire into a large group of people, it was still fairly effective. The musket was heavier than the arquebus, so it had to be fired off of a stand because it could not be carried or held into arms, at least stably enough to shoot. And the musketeers were the first soldiers in essentially European history to wear absolutely no body armor, because the weight of both armor and the musket together would limit their mobility to the point where they were very detrimentally affected. So instead, they operated from covered positions. They would hide behind walls, behind bushes, or else be protected by their pikemen. Also, because they did not need or did not wear any armor, and they did not use anything except for their musket and some gunpowder and balls, these were significantly cheaper to operate than even pikemen. And also the musket was significantly easier to train a person on than a bow and arrow, so these became very quickly the preferred type of troops throughout Europe in the second half of the 1500s. The first time that the musket was used in large numbers was in the Battle of Pavia. According to some historians, this can be considered as the last battle of the Middle Ages or the first battle of the modern period. This was the first time that the musket really made its field debut, and they proved to be extremely effective against armored cavalry. In this battle, the Spanish fought against combined French and Swiss forces, where the French armored knights, who used to be the terror of all Europe, were completely massacred and decimated by musket fire from the Spanish. After this battle, there was a little bit of a revolution in European land warfare, where armies began to reorganize around firearms and specifically try to build up a larger amount of muskets in their arsenals, and the musket became the dominant infantry weapon, but still supported by pikemen and pike and shot formations. Infantry for all pretty much armies now were organized in pike and shot formations, rather than just the Spanish and a couple of other states. Right around this time, there's also the development of corn gunpowder. So gunpowder that we used earlier was really used as a fine powder. It was occasionally transported, rolled into a large ball, and before use, the ball would be crushed into a powder, and the powder would be poured into a gun or into an artillery piece. But there were a few problems with this. First of all, when you use it as a powder, usually the constituents would separate out from each other, so there'd be less power for the gunpowder. Second of all, because of uneven particle size, there was an unreliable performance. Sometimes you'd have larger particles, sometimes you have smaller particles, so the strength of the shot was different with pretty much every single round. And it was very easy for this powder to get wet and then essentially lose its ability to explode. Whereas in 1525, the first poured or granulated gunpowder was developed. So in this case, gunpowder was made into a paste, and then the paste was rolled into small corn-sized pellets. These were easier to load into a gun or into an artillery piece. It had better combustion because now the granules had small air pockets between them, which allowed for extra oxygen for the reaction. It gave more reliable performance because now particles were very consistently made, and this was more resilient to moisture damage than fine powder because you had a very low surface area for the volume of gunpowder in these pellets than you did with something that was more like a flour. Also, we see the appearance of classical field artillery. By 1480, we had a couple of important developments like wheeled carriages and trunnions that we saw in the last lecture. Now these were combined with more advanced metallurgical methods, which allowed people to produce more efficient guns. there was a new method to cast bronze guns that was muzzle up rather than the old method of muzzle down casting, which was derived from a method to cast bells. And for some reason or other, casting cannons muzzle up made them more resilient and stronger. So now guns were able to be made longer, narrower, lighter, which made the guns, first of all, more powerful, but also more mobile. And the other advantage of new casting methods is that it provided for a tighter fit between the projectile and the barrel, so you were able to have more energy from the explosion go into actually propelling your shot rather than just escaping beyond the shot, and you would lose that power. And once again, corn gunpowder, in addition to helping with the firearm industry, it also helped artillery as well. And right around the early 1500s, we have a bit of a disparity between the old type of cannons and the new types of cannons. The most powerful cannons that were preferentially used up to this point were wrought iron artillery. These were typically built up from iron bars held together by hoops, so the method of construction for the bombard that we saw last time. They were cheaper to produce than bronze because iron was significantly more plentiful, and they were able to usually fire significantly heavier rounds. However, cast bronze cannon could be cast in a single piece or cast solid and then bored out, so they would be easier to mass produce to the same type and easier to just produce in general. They were safer and more reliable because if a bronze cannon burst, it cracked, whereas if an iron cannon burst, it tended to explode. So the survivability of a bursting bronze cannon for the crew was significantly higher. The bronze cannons were significantly more resistant to rust as well, so they gave them a longer lifespan, and very important especially for naval purposes. And also bronze cannons were somewhat more aesthetically pleasing, so they were very much beloved by kings and emperors for essentially prestige. In response to the development of new types of artillery and to gun artillery in general, we have the appearance of new fortifications. So these were called star forts or bastion forts. The high, thin walls of the medieval castles have really gone away by this point, and instead what we have is these sprawling constructions that look like gigantic stars that have embankments for defense rather than very, very tall but very weak walls. And what essentially these things did was they produced a series of locations where defenders could have an artillery battery that would be able to cover the individual fields of fire from each individual corner of this bastion. So if an enemy was attacking the wall, it could either attack a corner, in which case it would be fired on by overlapping fire from two artillery companies, or if it was trying to attack a corner, it could be fired upon by the company protecting that corner, as well as artillery that would be at the bases firing just along the length of the wall. So it gave significantly better protection ability to the defenders, and the thick earthen embankments were a lot more difficult to destroy with cannon fire than just a tall stone wall. These were ultimately perfected around the 1700s by French engineer Sébastien de Vauban and Dutch engineer Menno van Koren. Their systems essentially have just layers upon layers upon layers of bastions with such things like redoubts, which are basically small little fortresses within the walls, which would hold local artillery companies, as well as multiple layers of trenches and moats and walls and embankments and so on and so forth. So with these fortresses, this was really the maximum fortification that was used in history, because these remained in use up into the early 1800s, wherever fortifications were used, and the appearance of air power in the 1900s took fortifications to a status of no longer being functional. For an example of a siege from the 1500s, and also the last time that the siege tower was used was the siege of Kazan in 1552. This was the Russian campaign against the Khanate of Kazan, one of the last vestiges of the Mongol Empire that was remaining. And at the siege, a Russian engineer by the name of Ivan Muratkov developed and built a siege tower reportedly in just one night for Ivan the Terrible's army. The siege tower was specified as 18 meters in length, 13 meters in height, and 8 meters in width. And on the bottom floor or two, it had 10 heavy guns, and on the upper floors, it had 50 firearms. And it was used to essentially go up against a defensive tower of Kazan and destroy the defenders, and then was instrumental in helping Ivan the Terrible take the city. On the naval front, we see the development of the galleon evolving from the carrack. The word galleon is, at least according to some historians, it was used because these had more a galley-like appearance. The hull was longer and narrower than with the carrack. The forecastle and the stern castle were brought lower and eventually removed completely. The bow was built with a protruding beak. On galleys, that beak was used for boarding. On galleons, that beak was used to essentially secure the front sail, the bowsprit sail. There was overall improvements in sails and rigging so that the ships were more effective and more efficient at sailing, and we see a greater use of something called the tumble-home hull. And the tumble-home hull, basically, it's a hull which is widest at the waterline, and as you progress upwards, it narrows inwards. The reason that this was used is that cannons were very heavy, so if you mounted cannons far out beyond your center of gravity, when the ship was rocking in the sea, it could easily capsize and tip over and sink. So by using a tumble-home hull, you take the cannons closer to the center of mass so that you can rock to a greater angle without capsizing the ship. The best galleons in the 1500s, towards the end, were built by the British or by the English, and two instrumental figures in here were Admiral Sir John Hawkins, who started out as a privateer, essentially a pirate, and then was promoted to a naval commander in Queen Elizabeth Navy, and ultimately became a shipbuilder and a ship designer because he had a lot of experience, so he had a lot of very good suggestions that the shipbuilders who never sailed couldn't possibly figure out. And there was also Matthew Baker, who is believed to be portrayed here. He was a master shipwright and one of the three major shipwrights that Britain had. He was the first engineer to use paper schematics. Earlier engineers used scale models or just built the ships based on know-how. He was the first one who used schematics to both discuss the design of the ship with both commanders and other engineers, and the first one to use schematics to essentially record all of the design decisions that were taken in the development of some ships, so that that information was not lost if somebody was dead or something. The primary type of galleon that the British built was called the race-built galleon. It's not because it was used for racing, but rather because they raised the castles and made them lower. The ships were made longer, so compared to earlier ships, which would used to have a length to beam ratio of around 3:1, these was extended to 4:1. The castles were shrunk or raised down, or in some cases completely removed. The gun decks became lower, down in the water, or down closer to the water, so that made the ship overall stabler. There was now more space for large cannons because of the design of the ship, and there was superior mobility because both of the better design of the structure of the ship that goes underwater and improved sailing. A few important galleons which then led to improvements for the British fleet in general was Foresight. That was the first race-built galleon that Britain built in 1570 with 28 guns, and then the Dreadnought and Revenge in 1573 and 77, both of which were designed by Matthew Baker for 41 and 46 guns. And the Revenge in 1577 was the first ship with a deck that was just a gun deck. So earlier ships would have a deck which had guns but also had storage and a bunch of other things. This was the first one where they took an entire deck and just dedicated it to guns and did not have either sleeping arrangements or crew accommodations or supplies and so on and so forth. An important moment in the development of the galleon was the Battle of the Spanish Armada, and specifically the Battle of Gravelines, which was one of the engagements fought against the Spanish Armada. In this case, we see the comparison of essentially the old and the new schools of naval warfare. The Spanish Navy, which came with a significantly larger force, they attempted to focus on boarding attacks and really only intended to use cannon as secondary support. And in this battle, the majority of Spanish cannon were the older type, which were made out of iron. They were very heavy and had very, very large shells, were basically cannonballs, but they were significantly shorter ranged, and most cannons were actually only fired once because there was so much clutter inside the ships that they couldn't really wheel them in to reload because these were muzzle loaders. Whereas the British, they focused on the new tactic of long-range gunnery, and their ships, which were lighter and more maneuverable and had longer-range guns, basically just kept on maneuvering around the ships of the Spanish Navy, staying out of range of their guns and obviously their boarders, and just blasting them out of the water with their long-range guns. And the majority of these English cannon were the newer types of bronze guns. They were more accurate, more longer ranged, and even though they had lower or smaller shells and smaller cannonballs, they were still more effective because they could hit the target at long range and the Spanish could not. Ironically, most of the Spanish ships of the Spanish Armada sank because of a storm and not because of gunfire, but the battle showed the new tactic of using guns specifically rather than boarding or some older types of attacks was preferred and was more effective. Meanwhile, in the Mediterranean, we have some developments in the world of the galleys. The galleys in the Mediterranean right around the 1500s evolved into something called Ascaloccio, and these were the classic galleys that people usually think of, driven by hundreds of very miserable slaves. The galley Scaloccio type essentially had a lot of people on a single oar and then only one bank of oars. And the advantages of this is that it was a lot easier to just put untrained rowers because you only needed one person at the end of the oar to know what he was doing. Everybody else just provided the muscle power. So for these galleys, both the Turks and the Venetians and everyone else who used them tended to use either slaves or convicts or prisoners of war and other people who were not desired to be employed in other more meaningful ways. And in this case, because most of the crew was pretty much unwilling to be there, they were all chained in while at sea. So if the ship went down, then all of the crew went down with it. The advantage to the Scaloccio galley, in addition to just being easier to train people or not having to train people at all, is that they were now broader and therefore more stable. Therefore, they could carry a heavier gun in the front of the ship. The Scaloccio galleys were still driven by lateen sails, just like their ancestors a couple of hundred years before them, and the main armament now consisted of cannons rather than catapults or some other throwing devices. And these cannons, just like earlier, were still mounted in the forward section and were intended to fire forwards primarily. There were also some smaller swivel guns mounted along the sides to be manned by gunners, so essentially very large muskets, but these would have been primarily used for essentially in preparation for boarding another ship. And once again, the main weapon of the galley still remained the boarding party. So while cannons were expected to do some damage, the primary method of warfare was to board and then take another ship and either kill its crew and take over the people who are manning the oars, or just let the ship flounder and hope that nobody on that ship is going to be trying to kill it anymore. In addition to the galley, we have the appearance of something called the galleass. This was developed from significantly heavier merchant ships, also galleys but not used for war earlier. These were therefore larger, both in length, beam, and height, and a lot more stable. When the galleass was developed, there was a very significant structure built as the forecastle, and some structure built as the aftercastle as well. And these were used to house a very, very large number of cannons in comparison to other galleys of the time. So what these ships became was essentially sort of a cross between a ship that you would see in the north, like a galleon with a large number of cannons, and a galley which is primarily driven by oars. The galleass eventually was adopted by a number of navies, although not quite as popular as the galleon up in the north. And their last really major use was the Spanish Armada battle, where the Spanish sent a number of their galleasses, although a lot of them just did not make it because of stormy conditions. And these ships, being still lower and less seaworthy than the galleon, were happier in coastal waters, but very, very much at risk when they made it out into the open sea. The Battle of Lepanto in 1571 was the last major battle that was fought between primarily galley fleets, and it saw the first deployment of the galleass by the Venetians. And in this case, the Venetian galleasses essentially became the atomic bomb of the Christian alliance in this battle, because the Turkish fleet, which was significantly larger numerically, decided to begin the battle by charging the galleasses because they thought that these were just trading ships. So when the Ottoman galleys made it into range of fire, all of a sudden these trading ships began shooting at them with hundreds of cannons. And the Turks lost at least 70 of their galleys in that first attack. So that helped even out the odds a little bit, but ironically, even in this battle, the final outcome was decided by boarding actions, and specifically the boarding actions of the Spanish tercios, which were Spain's primary pike and shot formation troops. After the Battle of Lepanto, the galley really began to decline, primarily because it was just a significantly poorer type of ship than the pure sailing warship. The galley was basically useless in the open sea because it was very low and very, very much unstable compared to a significantly larger ship with just sails. And they were vulnerable to weather even in coastal regions. So it would be, in general, a very unsafe bet to try to put the majority of their fleet into galleys because they could just be taken out by storms. Large ships like a galleon, which you see in the middle here, were basically invulnerable to galleys. First of all, they had much taller sides, so a galley crew could not possibly board the ship because they would have to essentially scale the wall full of cannons. They were built much sturdier, so galleys couldn't possibly hope to ram them. If they rammed a large galleon, they would just break apart themselves. And there was a significant firepower advantage because while a galley at best carried maybe 5 cannons, a galleon could carry 50. So if a galley came to attack such a ship, it would probably be blown out of the water before the ship really noticed what was going on. And there were, in fact, cases such as an attack by Sir Francis Drake, I believe on Cadiz, where he came in with a single fully rigged sailing ship and took on 36 galleys and then won and then left because he was bored. So the galley really was not as good of a ship of war once the truly fully rigged sailing ship appeared. However, they did remain in limited service with some countries because they were useful as coastal patrol vessels where you could not send in a larger ship because it would be because the water was too shallow, and they were occasionally used to tow becalmed sailing ships, but this was more around ports and near ports because once again a galley going out to sea in the middle of the day or the night was essentially asking for trouble and basically bad weather to sink it. The last type of oared warship that was used in any significant number was this really weird thing called the oared frigate. It's essentially a hybrid between a galley and a sailing frigate. And these were used most importantly by Sweden and Russia in their wars in the Baltic. So as a frigate, this had a full rigging of sails, but also it had a full set of oars for maneuvering, especially around shallow waterways, and it had a full broadside of guns. And with these, there were a couple of generations, especially among the Swedish Navy. At first, the guns were mounted above the oars, because that makes sense. You want to make sure that your oars are not going to be shot while you're shooting at the enemy. But this arrangement was not very stable because guns are significantly heavier than people and oars. So after this, the Swedish attempted to put their guns in row with the oars. So essentially you have a bunch of rowers with an oar, then a gun, then another oar, then a gun, then another oar, then a gun. But it turns out that the most stable version was mounting the guns below the oars, which on the one hand, it added stability and it added maximum firepower because now you can mount heavier guns without fearing that your ship is just going to tip over and capsize. But on the other hand, it meant that your crew had to raise all of the oars in order to be able to fire, because if they didn't, then the oars would be completely shot off and you'd be back to just a sailing ship with a bunch of broken sticks sticking out. So these ships were used at battles like the Battle of Gangud between the Russian Empire and the Swedish Empire, and after the decline of Swedish power up in the north, these ships also essentially went their way into extinction. Also in the 1500s, there were some generic advances among siege technology from the naval front, and a good example of those siege technologies was the Siege of Antwerp in 1584-1585. This was the siege. This was a siege by the Spanish, and in this case, they built a 730-meter pontoon bridge to block off some waterways of the Dutch, and also to essentially make an armored wall where they could control the movements of the Dutch and they'd be at an advantage. The Dutch defenders attempted a few times to dislodge the bridge with explosive fireships, but each time the Spanish sent out their own boats and diverted the fireships away from the bridge, even though most of the crews of the Spanish that went out to do these perished because when the fireship exploded, it took out their boats with them as well. But the pontoon bridge was still kept safe. So what the Dutch did as a last attempt was they built this gigantic armored barge called Fin de la Guerre, and it was basically a giant floating platform with a castle built on it. It carried 1,000 musketeers, and according to some descriptions, it might have used some iron plates, which, if true, would have been the first example of using naval iron armor in Europe. But the vessel was way too heavy, and it very quickly ran aground because the water was very shallow, and the Spanish essentially ended up taking over Antwerp because the Dutch gave it up after the ship had failed. Meanwhile, there were some developments in naval warfare in the east as well. The Japanese Navy, around 1590, for people who know a little bit ahead, this is right around the time of the Japanese invasion of Korea. The Japanese Navy at this time was still primarily focused on boarding attacks, so their ships were not nearly as well armed with cannons and artillery in general as were European ships. In this case, most of their ships were built with sharp V-shaped prows, which allowed for relatively good speed, and they had deep draft, which made them stable, but it also gave them a high turning radius. And the superstructure on top was typically just made out of very thin boards, which meant that the superstructure was light and the ship had better speed in general, but it also meant that it was significantly more easily damaged by cannon fire from an enemy. Also, the entire structure was held together by iron nails, which made it strong initially, but over time, as the iron began to rust, the rusting nails actually then weakened the structure of the ship. And in terms of armament, usually these ships would carry a very small number of light cannon, usually no more than 5 even for the biggest ones, and primarily focused on having a very large number of arquebusiers, or essentially riflemen, and some number of melee troops to then board and take another ship by fighting hand-to-hand with swords and spears. The lightest type of ship that the Japanese Navy operated around this time was the kobaya. It was basically a light boat for patrolling communications. It had a hull covered by just an open framework, and sometimes the framework would have protective curtains to stop arrows from penetrating and hitting people on the inside. But those were really more for very light duties or very fast attacks. And it was manned by 20 oarsmen and 10 soldiers, among which you had 8 arquebuses. So the soldiers were trained both to fire and to use a sword. So at distance they would use the arquebus, and then when they boarded they would drop the arquebus and then go into battle with their sword, or their pole arm. The primary type of warship that the Japanese Navy operated at the time was the sekibune. It was essentially similar to a kobaya, but somewhat larger. And instead of having curtains, it had wooden panels to protect the men on the inside. This one usually had 40 oarsmen, although towards the mid-1600s it grew to as many as 70. And it also carried 20 soldiers, among which there were 20 arquebuses and 1 light cannon. The largest ship in regular service was called the atakebune, and these had up to 200 oarsmen in their largest variants, but typically it was closer to 80 to 100 men each. And for these, the prow and stern were still shaped like a V, but squared off at the very end, because essentially to lighten the construction a little bit. And these were armed with 5 cannon instead of just 1. And once again, the focus was on having essentially riflemen on board, engaging the enemy with long range and relatively accurate fire. Also, according to some descriptions, they might have had some iron plating on their wooden side panels, but descriptions from both the Japanese and visiting European sources are very, very inconsistent on that detail, so there's not very much consensus among the historical community. And finally, there was something called the o-atakebune, which were very rare. Only a few of these were built. These were up to 30 meters in length, and in general, they were more trouble than they're worth, because it was found that they were very difficult to maneuver, although these were armed with significantly more cannons than even the atakebune. So the profile that you see on in the side is an o-atakebune in front of a regular atakebune. So it was significantly larger and broader and beamier. And these would have been essentially used as the flagship of a navy, where the admiral would sit and command the rest of his fleet. And right for the invasion of Korea itself, they had one particular supership, which was called the Nihon Maru. This was the flagship of Toyotomi Hideyoshi during the invasions. The superstructure was described as having been 3 decks tall and 33 meters in length, and it's very likely that it was originally some royal barge, or basically a royal ship that he used, which was converted to military service as he decided to invade the Korean Peninsula. Usually in the attacks against enemies, the Otakebone or the Otakebone would be surrounded by a fleet of progressively lighter ships. This is very similar to what we see with modern fleets and European fleets of the time in general, where the big ships are forming the core, and they are surrounded both for protection and for ease of command by progressively lighter ships. And in case of attack, either against Koreans or against fellow Japanese, usually what would happen is the light ships, particularly the second Muni, would attack and charge forward in triangular formation following the leader. This meant that it was easier for the leader to command the rest of the fleet because they all saw where he's going, and it also meant that the leader could choose the specific point of attack based on the circumstance and didn't have to try to send out very desperate commands to have the rest of his fleet try to turn when they were not able to hear those commands. And once made contact with an enemy fleet, usually they would capture vessel by essentially ship hopping from the front to the back. But once again, the focus was on boarding and capturing enemy ships rather than sinking them. The invasion of Korea in 1592 involved 9,200 ships, although most of these would have been primarily just troop transports rather than combat ships of some specific sort. Facing the Japanese, you had the Korean Navy. And the Korean Navy had a number of ship types. The most important one, numerically, was the Panoxion. The first one of these was built in 1555. It had 2 decks. The lower deck was completely closed off, and it was used for the oarsmen and supplies and essentially everything that was not vital to battle itself. It also had a overall around a walled upper deck for troops and artillery, and a raised observation platform where the admiral or the captain of the ship could observe both everything that happens on the ship and as well as the rest of the battlefield or the battle sea around him. These were built from significantly thicker and sturdier beams than most Japanese warships, so they were able to be, they were much more rigid and much more stable as platforms. And unlike the Japanese, where even their larger ships would not carry more than 5 guns, the Panoxion usually carried at least 25 heavy cannons, and on larger types of Panoxion, there were reports of carrying as many as 50 cannons. The hull was flattened at the bottom and cut off flat at the front and the back as well, and that made it significantly shallower than the hulls of the Japanese, which gave these ships both very good maneuverability as well as good performance in shallow waters. The length of the Panoxion was usually around 20 to 30 meters, and these would usually had 60 oarsmen and about 120 soldiers among all of their cannons, their arquebus, and their swordsmen. The primary artillery used by the Korean Navy, and especially on the Panoxion, was something called the Chongtong cannon. There was a number of different types, like the Cheonya Chongtong, the Jija Chongtong, and the Gyeonja Chongtong. These were classified by their caliber, their mass, the mass of their projectile, and their range, where the largest one would fire a 130 millimeter projectile, and the projectile would weigh around 30 kilograms and could be fired to a distance of 1.4 kilometers. The projectiles look sort of like rockets, but they're not rockets. These are wooden darts with an iron case around them and then fins. These were the preferred type of ammunition for the Korean Navy because they had significantly better accuracy than cannonballs and somewhat greater range. But in addition to these, they also had iron and stone cannonballs, and some ships had explosive grenade shells that would essentially hit an enemy ship and then detonate on board. And of course, the most famous of the Korean ships of the period was the turtle ship, the Gyeobokson. This was inspired by the earlier Guiseon from the 1410s, although it is very likely that by the time of the Japanese invasions, the original Guiseon was already forgotten and none were in service, so Admiral Lee Sun-shin basically had to reinvent the turtle ship based on descriptions of the Guiseon. The hull was essentially based on a Panoxion, length of around 30 to 35 meters, and there were 10 oars per side, 11 cannons, and also 2 to 3 cannons both in the front and in the back. The crew was around 70 rowers and then 50 troops on the inside. The difference between the turtle ship and the Panoxion is that the turtle ship had a completely covered wood roof made out of very, very thick and sturdy beams. The roof was further topped with iron spikes, which prevented boarding, and because the Japanese primary strategy was trying to board a ship, if the ship is completely enclosed and has iron spikes, you can't really use your preferred strategy on it. Also, it is very likely that the top would have been covered by thin iron plates, whose primary purpose was actually not to deflect artillery, but to just protect the ship against incendiary ammunition. These ships are very often called the first ironclads, but it's not truly ironclad because the iron was here not for mechanical protection, but for protection against fire. Also, the turtle ship had a large dragon head at its front. It was large enough to fit a cannon, although with some ships, instead it had poison smoke projectors where some poisonous gases would be generated inside of the ship and then exhumed out of the front against enemy Japanese ships. The most famous battle of the Korean Wars by far was the Battle of Myeongyang in 1597. This was actually the second round of Japanese invasions into Korea, and the battle initially was Admiral Yusuchin's really last stand that he was prepared to make, because his navy was down to just 13 Panoxion, and he was facing a fleet with 120 Japanese warships of all shapes and sizes, as well as around 200 support vessels of various shapes and sizes as well. So in this battle, what Yusuchin did was he lined up his ships across the very, very narrow strait of Myeongyang, and in this strait there was a very strong tidal current, which in the morning was towards his side, but then towards the evening started going backwards. So he waited for the Japanese to advance into the current and have their navy be essentially forced together by the thin waters, and opened fire on them from all of his Panoxion, which had significantly better artillery than any of the Japanese ships. And then once the tide switched, the Japanese ships were essentially just bunched together, even closer than they were before. So in this moment, he attacked with all 13 Panoxion because his ships were significantly more rigid. He could ram enemy ships. He could fire at them with all of the cannons he had. And in the battle, he sank around 30 Japanese ships, but didn't lose a single one of his own. Although after the battle, he still needed to retreat because the Japanese still had a significant advantage, and he withdrew further up north to meet up with a friendly fleet coming up from the north. And this is an illustration from an earlier battle where we see the turtle ship compared to the Nihon Maru, the flagship of the Japanese Navy. So while the Japanese ship was significantly larger, it still had a disadvantage in cannon even compared to the turtle ship. So that particular engagement led to a fairly large amount of destruction for the Japanese fleet and almost the loss of the Nihon Maru itself. Also, right around this time, we see the birth of the submarine as a concept. The first hypothetical design was drawn up by an English mathematician called William Bourne back in 1578. In this case, he designed a completely enclosed wooden shell that would have been covered in a leather sheath for waterproofing. And on the inside, there would have been 2 flexible leather bags that would act as ballast tanks, and there would be screws on the inside that would push plungers in and out to allow water in and out of the bags so that the submarine could dive or surface. This particular design was never built, and it doesn't really seem like a design that there was any space intended for the crew, but we see that it's the first serious attempt at answering the question of how do we put a man underwater and have him be able to move around and do something useful. The first successfully tested submarine was built by Cornelius Jacobson Drebbel in 1620 for the English Navy. This is a replica that's seen here, and that is a painting of the ship done significantly after the demonstration. The ship that was built by Drebbel was also wooden and covered in leather, just like the design that we saw earlier. The diving mechanism was unfortunately not specified, but it's possible that he would have developed it off of Bourne's idea. And the diving depth was kept down to 5 meters. and according to some records from Dremmel's son, it seems that he might have been able to determine the depth to which he dove by a mercury barometer that he kept on board. Also, the ship was driven and steered by oars, and according to some historians who looked through the diaries of specifically, I believe, his wife, he had onboard oxygen provision by burning saltpeter. Because saltpeter is an oxidizer in gunpowder, he seems to have been able to figure out that if you can break down saltpeter, it'll provide oxygen, and you would be able to breathe even while underwater. In 1620, he tested his first one, and by 1624, he tested 2 more submarine designs. The largest one in 1624 had 6 oars, although it's uncertain whether that means 6 oars in total or 6 oars per side, and it could carry 16 passengers on the inside. It submerged into the Thames River in London for 3 hours and kept on moving underwater, and by the time that everybody thought that Dremel had died, he surfaced and came back out and basically said, "Look, I'm still here. We were just swimming around for a few miles here, a few miles there, and we came back." And it may be possible that the description is a strong exaggeration by historians and reporters of the time, but he did take even King James I down in the submarine, making King James I the first monarch to go underwater in a submarine, and King James seems to have survived the ordeal. So it is indeed the first submersible vehicle that was actually tested and shown to work. Over the next few, decades, we see iterative design from various other scientists and mathematicians and developers. This is a design from 1692 from a Frenchman by the name of Denis Papin. In this case, he had a submarine whose diving was controlled using both an air pump and a water pump to control the amount of water going into and out of the ballast tank to control buoyancy. There is the 1747 design from Nathaniel Simmons. It was built, it was essentially an extension of concepts proposed by Italian engineer Giovanni Borelli in 1680. And in this case, once again, you're using a bunch of leather bags as the ballast tanks, but instead of having them be on the side and pushed out and having water pushed out by a plunger, in this case there's a mechanism to twist the bags to expel the water, and the bags are more independent from each other, so there is more control over how much water is expelled and from which part of the ship it is expelled as well. The first submarine intended for military service was built in 1724 by a carpenter by the name of Yefim Nikonov for Tsar Peter I of Russia. It was basically a barrel with waterproofing on the inside, and it was intended to be armed with some tubular explosive charges that would be set under an enemy ship with a harpoon and then left there to explode like a delayed action underwater mine. But unfortunately, after the passing of Tsar Peter I, Nikonov was essentially demoted back to carpenter, and the submarine design was never pursued to do a full field test. Although the reports say that the submarine without weapons was able to dive and surface and spend some time underwater relatively safely. And we get to the flintlock. So the flintlock was first developed and patented by Marine Le Bourgeois in 1640. It was a development on a number of earlier types of gun locks, which also used flint, such as the wheel lock, the snap lock, snap hacks, dog lock, and a bunch of other designs. In the flintlock that was developed by Bourgeois and basically kept on being used for almost 2 centuries, you had a piece of flint held together in a hammer that would descend down. As the hammer descended down, it pushed against this curved piece of steel called a frizzen, and as it pushed against it, it generated sparks. The action of the hammer pushing against the frizzen also pushed the frizzen backwards, and as it was pushed backwards, the sparks reached the flash pan, which was right below the frizzen, and ignited the powder in the flash pan, which ignited the powder in the chamber and fired the gun. This design was significantly easier to use than earlier designs, and also because the pan was closed by the frizzen while the gun was not used, you did not need to worry that accidentally dropping your gun or putting it upside down would have all of the gunpowder pour out of the flash pan, and you would have to apply a new set of basically a new little bunch of gunpowder into the flash pan again. By 1630, the flintlock had proliferated throughout Europe and essentially remained the predominant firearm into the mid-1800s when you had the development of the percussion lock. And one of the first people to make very good use of the flintlock, among a number of other innovations, was King Gustav II Adolf of Sweden, or Gustavus Adolphus as is his Latinized name. He did a lot of innovations for the Swedish army, many of which were borrowed from other armies of the time, but a good number of which were his own developments. He introduced new army formations, where instead of taking deep squares of the pike and shot formation, which might have been as many as 50 rows deep, he took his infantry into wide but narrow lines of 5 to 6 ranks, and this had the effect of improving mobility. And technically, a similar formation was first used by Maurice of Nassau, but Gustav took that formation and made it standard for his entire army throughout. And in addition to broadening out the infantry, he put gaps between infantry formations. These gaps could be used by cavalry and artillery, both to attack forward and avoid hitting your own infantry, and in case the cavalry needed to get back and regroup behind the infantry, those could be used as channels to retreat and regroup and then attack forward again. The three branches were drilled to operate together in mutual support, which basically means that Gustavus was one of the first people to develop the concept of combined arms. He was also the first person to put true mobility into his artillery. He used light artillery, including 3-pounders and 6-pounders, grouped in mobile batteries, and these were intended to move around the battlefield with the rest of the army and provide heavy fire support as needed, instead of doing what ground artillery did earlier, which is essentially just sit in a single spot and hope that they can shoot somewhere where it is useful. Usually artillery prior to this were only used at the beginning of a battle, but during the battle they could not provide much support because either their position was no longer advantageous or they were already just going to be shooting at their own troops instead of the enemy. He improved the training of the Swedish army so that it was basically the best in Europe at the time. Most troops were trained in pretty much every single available mode of fighting, so the pikemen knew how to shoot a musket, the musketeers and the cavalry knew how to load artillery and fire it, the pikemen and the musketeers knew how to ride on horseback, and essentially everybody could fill in everybody's position to a certain extent. This was demonstrated a number of times when his cavalry had to man the artillery and did so fairly well, whereas in other militaries, usually every branch was just drilled in its own form of combat. So if your artillery crews were killed, you basically had no more guns because nobody knew how to use them. The musketeers were drilled to fire in salvos from 2 to 3 ranks at once, where the front rank would kneel, the second one would crouch, and the third one would stand. This meant that you had a lot more firepower coming from a single salvo than just from a single line of soldiers. And because his lines were a lot broader than a lot of the other European armies, that further increased the amount of firepower that's coming in from a single shot. Then after the salvos, which would happen very frequently at close range, then it would be followed by a pike and sword charge into the very dismayed and shocked enemy. Musketeer troops were also deployed along with the cavalry in support of them. This meant that the cavalry had their own gunners supporting their operations and made the cavalry significantly more effective overall as a fighting unit. This tactic was called the commanded shot. Also, in addition to improving the tactics and improving the formations, he improved the equipment, where he issued standardized light handheld muskets and paper cartridges to all of his musketeers, and standardized field artillery pieces and artillery shot. Regarding the artillery, he was one of the first kings to put a standard breakdown on artillery types that were in service with the army. He used 24-pounder, 12-pounder, 6-pounder, and 3-pounder guns. A similar pattern was used by Maurice of Nassau, who also developed the broad but narrow lines for the infantry. And specifically, the lightest pieces, the 6-pounders and 3-pounders, were integrated into the field army itself. There were 6 guns for every 1,000 infantry, and these and their carriages were sufficiently light so that they could be moved by their own crews on the battlefield to some extent. So therefore, they were able to respond to the changing situation in the field instead of just sitting stationarily in some random position. The rate of fire was significantly higher than earlier heavy artillery, in part because of the significantly better training of the crews, in part because of the lighter shots that were used with these guns than the very heavy boomers of earlier decades, and in part because eventually he started using unified cartridges which had both the powder and the shot, so he only needed to load one thing into the gun instead of 2 things. And he was the first person to begin to widely use canister shot against enemy formation. So a canister shot is essentially a bucket full of shrapnel, usually musket balls, which is fired instead of a solid cannonball. So if you're attempting to hit a large grouping of infantry, a canister shot will be a lot more effective than just a solid cannonball. Among the rest of his army, his cavalry and infantry received significantly better equipment as well. The cavalry were armed with broadswords, flintlock carbines, and flintlock pistols. The musketeer infantry was given a light flintlock musket, which was light enough to be held in two hands without needing a fork. So that meant that the musketeer troops were a lot more mobile, and they were no longer required to essentially put a gigantic fork into the ground just to fire. They were also armed with rapiers and glaives as necessary, and the pikemen were armed with a long pike, a rapier, or a broadsword, and daggers, among other things. Roughly around the same time, we also see the development of the first man-portable mortars, which were the first light, essentially siege artillery. These were developed by Menno von Coehoorn, after whom the Coehoorn mortar is named, in 1674, while besieging the city of De Graaf. This, once again, was the first man-portable siege mortar. Earlier mortars were many, many tons in weight and had to be brought in by large horse crews. The Coehoorn mortar could be brought in by 4 people and loaded by a crew of just 2. It fired a time-fused explosive shell instead of solid shot, so the soldiers were now able to use significantly more effective ammunition rather than just solid balls of steel or gunpowder. And the high arc of fire from the Coehoorn mortar allowed shells to fly over defensive walls and embankments, which meant that now you could use them to attack the inside of a fortress instead of having the shots bounce off of the gigantic walls and dirt walls. Also, we see the development of the bayonet. The first bayonet was issued to French musketeer troops in 1647. These first bayonets were plug bayonets, so they were stuck into the barrel of the flintlock, and therefore you could not shoot the gun while the bayonet was installed. The socket bayonet was first developed also in France in 1689. This was designed to fit over the barrel so that the musket could still be fired while the bayonet is on. But the problem was that these early socket bayonets very easily fell off muskets when they were being used. So in 1703 there was a spring system developed that kept the bayonet on the musket even as you fired the musket and did various military operations with it. And by 1705, England, France, and Germany, and very soon afterwards the rest of Europe, because of the appearance of the bayonet, they abolished the pikeman. Because all of a sudden, the musket with a bayonet essentially was a pike of its own, so therefore you did not need to diversify across 2 types of infantry. You just had one single uniform type of infantry that was able to both defend with a pike and attack with a musket shot. And in 1715, there was the triangular blade bayonet, which was introduced. This was stronger and stiffer because the blade of the bayonet was more difficult to bend than for just a single 2-dimensional blade bayonet, and also the damage from a triangular incision was a lot more difficult to heal on a soldier than just a flat incision. So by 1717, we see the appearance of the first true standardized musket developed by any military in the world. This was the Charleville smoothbore flintlock musket for the French army, developed and standardized in France first in 1717. It gave a maximum sustained rate of fire of around 3 shots per minute for a well-trained soldier, and the shoulder stock was designed so that it could be used as a club. So with this weapon, you essentially have a musket, which you can use to shoot. You have a pike with the bayonet that will go on the musket, and if all else fails, you can just at least use it as a club to just bash people over the head. The total number of muskets that was produced of this type was around 721,000. The models were updated in 1717, 28, 63, 66, and 1770. And then finally in 1777, the design was further modified into the musket model 1777, of which 7 million were produced up through 1826. So this was essentially the exact same design, but with overall improvements to the structure, to the accuracy, and to the stock as well. The response to the Charleville and eventually the model 1777 musket was the British land pattern musket, also called the Brown Bess, also a smoothbore flintlock. This became Britain's standard musket between 1722 and 1838, and over 4.3 million of these were produced. There were a number of varied families, including long guns for the infantry, shorter carbines for the cavalry, also shortened guns for use in the Navy, and a bunch of specialized variants as well. And we see the beginning of experimentation in guns with revolving chambers. The first experiments in putting revolving chambers on guns was as early as 1580, but these were very, very expensive, difficult to use, and therefore not adapted for service with anyone. In 1717, we see the development of the puckle gun. This was a flintlock revolving gun with a handle in the back and a bunch of chambers, and in principle, it was able to fire as many as 9 rounds per minute. So over the course of 7 minutes in a 1717 test firing, it was able to send off 63 shots. It was 3 times better than contemporary muskets, but unfortunately the gun was also way too heavy, way too expensive, and not very reliable, so it was not accepted for service either. And finally, to close today's lecture, we have a little bit on the ship of the line. The ship of the line evolved from the galleon after the battles of the Spanish Armada, as now navies were attempting to put more and more and more artillery guns on board. The castles now were effectively completely flattened out. This meant that you had a longer continuous deck to mount heavier guns, and you could put more than 1 deck of guns. And the first ship that had as many as 3 full gun decks was the British ship, the Prince Royal, launched in 1610. It had 3 full gun decks and mounted a total of 70 guns. As the ship of the line evolved, various navies introduced ratings for ships of the line. The first one being the British rating system, also introduced in 1610. These ranged from the first rates, which were the largest ships, to the sixth rates, which were the smallest. First rates typically mounted 100 guns or more on deck, and a good example of this is the Sovereign of the Seas. It had 3 gun decks and was eventually built to carry 102 guns on board. I believe that this was the first ship that had more than 100 guns on board built by anybody. Second rates were somewhat smaller, usually had around 80 guns. The most important type of ship, at least numerically, were the third rates. These typically mounted 50 guns initially. Eventually they evolved into the 74 gunner, first built by the French and then widely adopted by pretty much every other major European navy. And a very important characteristic of ships of the line in general, regardless of the rate, is that they have to be comparable to each other. Because if you had a line of ships which were very, very powerful, but then one very weak ship somewhere in the middle, and that line came up against another enemy line, then that weak ship would be very easily blown out of the water, and that would create a breach in the line, which could then be very easily taken advantage of by the enemy, and your entire naval line would collapse. So therefore, when these ships went into battle in linear formations, admirals had to make sure that every ship was essentially as strong as each other, so that no one ship becomes the weakest link in the line. The guns evolved with the ship, so as ships became bigger and heavier, the guns that they carried also became bigger and heavier. They became larger in caliber, and had longer barrels for a greater range of fire. Ultimately, these grew from something like a 24-pounder into 36-pounders and even 48-pounders that were ultimately used by the French. Also, around this time, we see the first attempts to protect the ship underwater against degradation. By 1690, the bottom of the ship was covered in lead sheeting, which would prevent both barnacles and essentially decay of the wood. And in 1708 was the first suggestion to use copper, but it wasn't adopted until significantly later. Lead sheeting was already used by the Romans earlier on, but that technique was sort of forgotten all throughout the Middle Ages. So in the late 1600s, the technique of applying a sheet of metal to protect the underside of your ship was basically reintroduced into the naval world for the first time in probably over 1,500 years. And among the ships of the line, there was primary competition between the English and the French. And around 1675, the overall comparison ran that English ships basically carried way, way too many guns for their size. French ships that were particularly built under Jean-Baptiste Colbert, who was Secretary of the Navy around the time, the French ship of the same size would have fewer guns, but their sailing characteristics were better, and the design, basically the designs were ultimately adopted by England and other navies who wanted to make sure that their ships not only carried a lot of guns, but could also outmaneuver, or at least comparably maneuver and sail to the enemy. And incidentally, around 1700 to 1710, you see the invention of the steering wheel, or the helm. It seems like something that would be really obvious, but until 1700, ships were still steered either by levers or convoluted systems of ropes and pulleys, but nothing like a wheel. So, very simple concept, took a really, really long time to develop. In addition to ships of the line, who were the big fancy boys of the Navy, you had the frigates, the lighter support ships. These were intended to essentially be very light but very fast, and for independent naval operations, such as escorting or chasing down pirates. Incidentally, the first ships that could be called frigates were developed by something called the Dunkirker pirates, who were serving Spain around 1590, and these frigates were used to harass Dutch merchant fleet, the Dutch merchant fleet. So the Dutch Navy built their own frigates in response to these Dunkirker pirates, and they put their first frigates into service around 1600. And technically, a frigate, as its overall characterization goes, it's a single deck, or it has a single gun deck. It's a fully rigged ship, which is smaller but much more maneuverable and much more mobile than a ship of the line. Initially, the Dutch Navy frigates were used to protect the Dutch merchant fleet and fight privateers, but ultimately they began to be used in naval combat against other ships as well. In 1639, they were decisively used against the Spanish at the Battle of the Downs, and after this battle, other navies also began to adopt similar ships for light duties that did not require a ship quite as large or quite as cumbersome as a ship of the line. This is an example of a Russian frigate from 1703 called the Standard, where you see it has a full sail plan, a single gun deck, and overall it's much more light and also much more mobile and maneuverable than a ship of the line would be. And in addition to the ships of the line and the frigates and several other types of warships, there was the evolution of the first ship specifically designed for bombardment of ground targets. And this was called the bomb ketch. This was the first ship that was armed with a mortar rather than long guns that would fire on flat trajectories. The first ones were built in France in 1681 and initially called galiote à bombe because the overall hull was derived from a ship called the galliot, which was essentially like a frigate but lighter and more maneuverable. The early bomb ketches had the front mast removed, so as we see in this model, there's no forward mast, there's just the middle and the rear mast. And in principle, this opened up the deck in front to make space for the mortar, or as you see in the picture on the top, but unfortunately it made the ship very, very difficult to maneuver or control in general. So what ended up happening was later bomb ketches had a full three-mast system, but they had mortars that were essentially just spaced around the forward mast or between the forward mast and the main mast so that they did not hit their own sails when firing. Also, in addition to particular structural in addition to requirements from the rigging, there was significant rework for the decks, so the decks were reinforced with much stronger and stiffer timbers to make sure that they could handle the downwards oriented recoil, because while other naval guns, essentially their recoil is sideways, and you can dampen it out with ropes and pulleys. With this one, the full recoil goes into the ship itself, so the ship had to be built much sturdier. And at the time, these were the only ships that had explosive shells, because for horizontal fire guns, explosive shells would only be invented a couple of decades down the line. Also, as you can see on this particular illustration, the bomb ketches still carried a few naval guns as well towards the back, just for self-defense. But because the front part of the ship had to be dominated by the mortar and artillery for the mortar, there were no guns in the front of the ship. And that is it for today.